Next, we are considering the properties of ferrous metals with respect to the amount of carbon contained. I am firstly introducing about strength and hardness. Basically, the higher the carbon content, the harder the materials tend to be. However, in the fabrication processes, properties against hardness, such as formability and ductility, are sometimes required. Properties such as strength and hardness of ferrous metals can be adjusted by quenching and tempering after fabrication processes. For example, you may increase the strength and hardness by quenching and tempering after the material has been processed in a lower strength state. As for the ductility, ferrous metals have higher ductility at lower carbon content. Machinability is also an important property of ferrous metals. Basically, the higher the carbon content, the harder it becomes. Harder materials are difficult to be machined. Carbon content up to 0.6% is good for machinability. Steels become even harder and more difficult to process about 0.6%. Cast iron, on the other hand, is hard and brittle, so its machinability is good. How the carbon content in ferrous metals influences the quenching effect is also important. Quenching is a process used to improve the strength and hardness of ferrous metals. However, if the carbon content is low, the ferrous metals cannot be quenched. So, no improvement in strength or hardness can be expected in this case. You can expect quenching process to increase the strength and hardness with steels of certain amount of carbon. Again, the important carbon contents are 0.3%, 0.3, 0.6%, and 2.1%. Hardening is expected when the carbon content is 0.3% or more. At 0.6% carbon content, where resistance increases. At 2.1%, the material is already hard and is not usually quenched. Casting, in general, have a complex shape. A part of complex shape includes wide variety of wall thicknesses. In such cases, the part is not quenched homogeneously, resulting in unwanted cracks. The carbon content also affects the weldability of steel materials. The carbon content, which is important for weldability, is also 0.3%. As in the case of quenching, when the carbon content is below 0.3%, welding is easy. When the carbon content is 0.3% or more, the heating in the welding process hardens and cracks. Here, the steel is quenched due to the higher carbon content. This is the reason why the carbon content, 0.3%, is a boundary as in quenching. The relationship between carbon content and melting point is also important. while the melting temperature of pure iron is 1500 degrees. The melting temperature of cast iron is as low as 1200 degrees. As the carbon content increases, the melting point decreases. Alloys containing impurities generally have lower melting points than pure metals. You may intuitively understand that the lower melting point of cast iron is advantageous, since casting is a forming method in which molten metal is poured into a mold. The important quantities in carbon contents are 0.02%, 0.3%, 2.1%, and 6.7%. These are associated with quenching, weldability, machinability, melting point, ductility, strength, and hardness. However, the carbon contents never influence on Young's modulus as a principle. So, the rigidity of ferrous metals are constant